You know that the initial energy plus the network equals the final energy. Initial energy is made up of kinetic and potential, plus the network, which we just calculated, equals the final energy, which is made up of the final kinetic plus the final potential. Well, what do we do with the potential energy terms? You only consider energies that change. That is really essential to this. You only look at energies that change. If there's no change in the potential energy, then it's unnecessary, because you'd have the same number on the left as you have on the right. It doesn't change anything. So if it doesn't change, we don't have to consider it. In fact, you don't even have to write it down. Well, the initial kinetic energy, you can go off to the side and calculate it. Let me just go off and calculate it right here. The initial kinetic energy is 1/2 mvi squared. And that's going to be 1/2 times the mass of 20 kilograms times the initial velocity of 15 squared. 15 squared, I think, is 225, and the half of 20 is 10. So 10 times 225, 2,250 joules. I should check that. I think it's right. Oh, what do you know? I've already done it. Yeah, 2,250 joules right here. So, 2,250 joules plus the 666 gives us the final kinetic energy, which is going to be, I'm calculated. It's late in the day and my brain is saturated. So that's 2,916. So the final kinetic energy is the sum of those two things. So KEF, right, that's that, equals 2,916 joules. So what this is telling us is that when this whole thing started, it had 2,250 joules of energy. It was all kinetic. Whoever was doing the work transferred a net of 666 joules into the system, into the box. So at the end of 10 meters, it had sped up, and now it has 2,916 joules of kinetic energy. Now we can find, for part C, its final speed. We know that this equals 1/2 mv squared. So 2,916 equals 1/2 times 20 VF squared. Solve for VF and then take the square root. It's going to be the square root of, that's half of 20 is 10, so that's the square root of 2,916 divided by 10. And I get 17 meters per second. It went from 15 to 17 meters per second in 10 meters.